Okay, we are now working on assignment 4, and this is the friction assignment. And the question was asked about question number 4, which is actually a tough question, so I'm glad this came up. Assignment 4, number 4. I'm going to draw you the picture. It's the one with the lawnmower in it. So we're going to draw the ground here, and here's our lawnmower. The question tells us that the lawnmower has a mass of 30 kilograms, so I'll write that inside. Okay, and the only other thing given is this applied force, which is pushing down this way. And it gives us an angle of 40 degrees for that. 40 degrees, that says 40 degrees. Okay. And they want us to find out how hard we must push. So this force applied is sort of what we're after. We don't have a number for it. Now this creates some problems because it's on an angle, it's both pushing down and pushing sideways, isn't it? It has two components. And of course we are going to have to find those components whenever you have a force on an angle. So I'm going to shift to a blue color here. We have to find this downward force right here, right? And then we also have to find this sideways force. These are the components. But the problem is we don't have a number for F applied. So what do we write? Well, in the absence of a number, we just use the letters. So we have F applied cos 40 on this side because we don't know how much it is. And we have F applied sine 40 on this side up here. Oops, I got the wrong pen here, sorry. F applied sine 40. One of the things you have to get used to in physics is if you don't have numbers, you just use the letters and you hope that things work out. So we've resolved this into its components. Now I can figure out the number, what sine 40 is. I don't need to keep writing sine 40 because it's just a number. So in my calculator I can do sine 40 and it's 0.64. So this is the same as 0.64 F applied. So that's a little bit simpler. And I can also do cos 40. Because it's just a number. It's 0.77 when you round it off. So this down here is 0.77 F applied. So those are the two numbers that I'm going to be using for my components of this force. But you notice they have F applied in them. We just got to live with that. What else do we have to worry about? Well, we also have a normal force, as usual, and a gravity force. Those are the up and downy forces. I'm going to draw them in green here. And a friction force, because the coefficient of friction was given to us as I'll do that one in yellow. Friction was 0.2. So that means there's a friction force. Now, which way is friction? It gets a little complicated here, doesn't it? Because the picture has lots of arrows. But the motion is to the right, because it's that F applied cos 40, that 0.77 F applied is the part of your push that's going to make it go sideways. So there is a friction force, which I'm going to have to add down below because I don't have room to write it right on the 30, but we'll just put it here to remind us that it's there, okay? All right, so now we've got all our forces. There's nothing else. Now look at the blue force. The 0.64 F applied is a downward force. It's pushing down, so it's not helping the lawnmower move. In fact, it's pushing it into the ground, which means that the normal force has to work harder. So it's increasing the normal force. We're going to see that in a minute. That means that it's kind of like extra work. Normally, we don't like to push down on things because it makes the friction more, as we'll see. But in the case of what we call ergonomics, which is the sort of making things comfortable for us to use. It's pretty hard to push a lawnmower by pushing straight sideways. You'd have to get right down on the grass and push it. So the handle has to be bent, and we make that exception, and we live with it. Okay, here we go. F net Y. It's going to be relatively big. So here's what you're going to do. Up and down forces, right? So the Fn goes here, the green ones, and the Fg. And don't forget the blue one. It's a downward force. And because I have the number for it, or at least I have part of it, it's down. I'll put the negative in, 0.64 F applied. Okay? If you want it to be really fancy, and you wanted to do this like, a really good essay written in good form, then what we would call this in this equation, we would put the plus in and we would call it F applied y first, which is the y component of F applied. And then when we put in our numbers, we would write MA here, FN, right? We'd write FG equals MG. And then here we'd have the negative because we're using a number 0.64 F applied. Right? So the 0.64 is the y part. That's the cos 40, or sorry, the sine 40, which made it turn into the y component. And then we keep on going. We expect the acceleration to be 0 in the vertical. The lawnmower does not shoot up into the air or dive into the ground. And what's going to happen here is we're going to be able to get our normal force, but it's not going to be pleasant. Down for gravity. The mass of the lawnmower was 30 kilograms, so 30 times 9.8. 0.64 F applied. Okay, well 30 times 9.8, we can easily do that part, and then we can see what this normal force is going to be. So we get 0 equals Fn, then we get 294 down for this one, and a down 0.64 F applied. So we want the normal force. That's what we're looking for with these F net y's most of the time. So I got to move everything to the other side. 294 plus 0.64 F applied equals the normal force. If you look carefully at this equation and you look at the picture, what this equation says is that the normal force is doing two things. It's taking care of this push down and the gravity down. So if you look at the picture, see the upward normal force is compensating for the two downward forces to keep everything balanced. Now that's a crappy looking normal force. But guess what? It's the best I've got. So you don't have to solve it anymore. You just keep it that way. This entire thing becomes my normal force. So I leave it and I go to the F net x. In this case, going back to the picture, I have only two arrows. I have the right facing 0.77 F applied, the red one, and I have the yellow friction. So I'm going to write F applied x here, the x component, and the force of friction right here. Okay, so what am I going to do? Well, I'm going to do MA. F applied x, I have a number for it. It's the red number, 0.77 F applied, and it's to the right, so it's positive. The friction is going to be mu Fn, so we'll just keep that here. Now you see what's going to happen. If I'm pushing the lawnmower at a constant speed, my A is a 0, so this side becomes a 0. Here I have 0.77 F applied, but now I can substitute for my friction. Friction is a left force, so negative. The mu given was 0.2, I believe. Now, Fn. Well, guess what I have to write here? All of this. I have to write the entire thing. 294 plus 0.64 F applied. That's the normal force. And I put it in brackets because it's got two terms in it. Now here's what you're going to do. You're going to multiply this into the brackets first. Then you're going to see that all you have left are terms with F applied. So you're going to group the like terms, and hopefully your F applied is going to pop out. So I'm going to let you finish that. Multiply that in, group the like terms, move things around, and solve for F applied, and that's how you deal with this one. So it's a bit tricky because this normal force is messy. But good physicists never get worried about mess. We just keep on trucking. Notice how we just keep doing the same thing. F applied, net, F net x, F net y, everything's in there, and it